Hello parents and good morning to all. In this lecture we will start a new chapter. So that is your partial differentiation. Okay. So the most of this particular chapter you have already learned in your 11th, 12th as well as in the F5 course also, so mainly in calculus course. So basically we will see in this particular what is the introduction of your differential equation, then we will see the partial differentiation if two or more than two variables, okay, independent variables are there, so we have to do the partial differentiation of that one. Then we will see the successive differential case. Again we will see the total differentiation, chain rule, theorem for differentiation, your change to function from Cartesian to the polar coordinate. That part we will also going to see, and lastly you have to find out mainly your point, okay, maximum or minimum point you want to find out, and that we can and we'll also see the problem section, unsolved problem section. So firstly we'll see the differentiation, okay. So before that we'll understood one graph. So this familiar graph, suppose the y is a function of your x, and here we have given one graph. This is x. Please remember, x is your independent variable and this y is your dependent variable. Okay, independent variable means we can take any value of x. On that x value your y value is defined. That's why this is dependent variable and this is your independent. So y is a function of x. Suppose we will draw one line just like this one, and another graph, okay. So this is very interesting if you see the graphical way, this. So in this case, suppose I want to find out the change, rate of change, okay. So what I will do, so I will plot a slope, okay. So for that purpose I will choose 2 points. Suppose this is my A point, this is my B point, and I will find out this point and this point. So here this is what? So your change in y, okay. So this is just like when you are finding out the slope of any graph. So this is y2 minus your y1 divided by your x2 minus your x1. So you can write that is nothing but delta y upon delta of your x, and that will denote your slope. But suppose I will choose a different point here and here, so you will get the slope of this particular, because here once your x is changed, your y is also similarly changed, and this is your line, okay. So in this case you will get, this is constant rate of a change. Constant rate of a change means on this line you can take any point, any 2 points, and if you find out the slope of that particular graph, so you will get a constant rate for change, okay. But if you see this particular graph, okay, and my aim is to find out the slope of this particular line. So in this region the stiffness is more. Stiffness is more means here the high slope, obvious, y2, change in y is larger as compared to the change in x. So within this x region your y is change huge, okay. So here you will get a high slope. Whereas suppose I will find out the slope in this particular line. So in your mind, why we are not taken a single slope just like this one? So please remember here in this case the slope variation is there. Slope variation means certain region your slope is high, certain region the slope is very less. See here, so y change is very small but x changes is larger, so you will not get constant rate of change throughout that particular curve. Okay, so what we'll do in this particular case? Okay, so in this case we have to do the tangent at that particular point. What do you mean by tangent? Okay, so this part we'll see. So basically this is your x, this is your y, and suppose your, okay, so here you will get a constant rate of change. But what happens here in this case, suppose this particular, so I will take the 2 points, this is point P and this is another point Q. So basically you have to find out the average slope, okay, average rate of change of this particular graph, and you will get. So best example, you have to find out the tangent. Okay, so tangent at a point x. Okay, so basically you want to find out what will be the change at an instant of point P. So at x is equal to this one. So in this case we can do this PQ. Okay, and here you will get, this is f of your A. Here you will get what? F of A plus your H, and this I will suppose write A, x is equal to A, and here we can write this is x is equal to A plus your H. Okay, so in this case we have to apply your tangent. Okay, so tangent at a point P. So in this case what I'll do, I will consider this particular triangle, suppose PQR. Okay, and this QR is represent what? QR is represent, so it is just like your f of A plus H minus of your f of A divided by A plus your H, this y2 minus y1 divided by x2, so A plus H minus your A, this goes cancel, and if you take on a limit H tends to 0, means basically you are doing delta x, smaller and smaller change. Okay, so that tends to 0, and this is f of A plus H minus f of A divided by your H. So this is represent what? Change along means this QR, this minus this. So I can write in graphical way, suppose triangle PQR. Okay, so this is QR upon your PR. Okay, PR, this is when happen, when Q tends to P, means the given point Q should be, because we are taken a limit, H tends to 0. H tends to 0 means the given Q2 point is closer and closer. The value is not 0. Okay, Q point is tends toward 0, means here, here, here. So at a certain point it is obeyed just like, instead of the curve line, so it is, if you are taken only a small change, so it is just like your straight line. Straight line means it is, suppose here we have taken a small change, okay, and that small change suppose magnifies, so it is just like a right angle triangle. So this is your QR. QR is depict what? QR is depict for your opposite side and divided by your PR. Okay, PR. So this is nothing but your tan of theta. Okay, so that's why the word is come a tangent. Okay, so this is a tangent at a point P, means when you have to find out the graph, that time will provide a tangent to this particular line. Okay, so if you remember last year we have taken mirror and we'll choose one particular point, just like a temperature. We'll give one point over there, and using that we'll do tangent at one particular. So this is the case. And what is the origin? Origin is nothing but this side. Okay, so this is basically your slope of the tangent line. Now over this particular, suppose this is my tangent, I will draw a separate curve, suppose. Okay, so this is my curve, and I will suppose provide a tangent at a point x is equal to something. So this is my tangent. So suppose I will expand the tangent line here also. So this is not touch again to that particular graph, means tangent is given, and over this line, suppose I will take any 2 points and I will find out the slope, and that slope is always constant. So here the two things, suppose the line is straight line, this one, here you will get a constant rate of change. In case of your continuously increasing function is there, just like curve nature of that one. So here you have to provide a tangent at a certain instant of points, suppose x is equal to a, and you will get this one. So basically the differentiation will find out how fast or how slow your function is varies. Okay, so this will be gives how fast or how slow your function is vary. Now in physics several terms are there. First is your time rate. Example, time rate means what? This is rate of change of velocity, that will give acceleration. Rate of change of displacement, so suppose this is your constant. Okay, so here you will get velocity is constant, but you will get velocity is constant, and from that graph, suppose you want to find out the acceleration is 0 because the rate is constant. So this is your displacement. Okay, so this is dy by dx. Dy by dx is gives you slope or rate of change of certain function. So this is y. Okay, y is a function of your x, and that will gives dy by dx, and dy by dx is nothing but rate of change of some function with respect to your x. Okay, so x is independent variable. So in case of suppose velocity, rate of change of displacement upon time, so x is belong to your time rate. Again acceleration, rate of change of your velocity with respect to the time, means the change with respect to some argument, that is called as your time rate. That is familiar. Second example, suppose this is one particular hot body. Okay, and you want to find out what is the cooling rate of this particular body. Okay, so simple thing, we can find out that rate also. The third example in physics quantity. Okay, so the pressure we know, this is van der Waals equation. Okay, so this is RT divided by V minus B. Okay, minus A divided by your V square. So this is your pressure term. So is a pressure is a function of your velocity, means volume, and your temperature, because R is constant, A is constant, B is constant. So this is one case is there. Second example, suppose the heat of transfer from one body to your another body. Okay, so that heat transfer is how much? Q is equal to K times A, theta 1 minus theta 2 divided by your x into t. This experiment you have performed in first year. This is your one bad conductor you can put in between your two discs. Okay, and how much heat is transformed from one body to another body. Okay, thermal conductivity of a bad conductor. So the Q is a function of your x, t, and this one theta. Theta is your temperature, t is your time, and this is your thickness of that particular bad conductor. Second is third is this is H is your enthalpy. Enthalpy is a function of your internal energy and your pressure and volume. So this is case. Gibbs free energy is there, Helmholtz function is there, okay, and famous example is your resistance of a wire, okay, so that is nothing but rho L by your pi r square. So r is a function of length of wire as well as radius of that particular wire. R is your resistance of that particular wire. So in many terms, the given function is depend upon several independent variables, just like L, R, V, T, theta, T, U, P and V, whatever. Okay, so such a case, this is called as your partial differentiation. Partial differentiation means what? If your function is depend two or more than two variables, means f is a function of something x, y, okay, so f is a function of x, y, or you can take two or more than two, so z, so in that case we have to do the partial differentiation. So that instead of we can write dy by d suppose x or df by dx, suppose we can't write df by dx here, we can write dabba f by dabba x, because the partial differentiation with respect to the x, this is not depend only on x variable, this is depend upon x, y, z, whatever that one. So that's why instead of d it will be changed to dabba. Okay, so now here suppose x, f is a function of your xy coordinate. Now the x changes to x plus delta x, means your function is changes with an infinitesimal quantity delta x, small change in x, just like this particular graph you have drawn, okay, and you have taken only small change in that x, so automatically your f function will be changed to f plus delta f. Please remember y is constant here, okay, so this is represent a 3D graph, okay, and if your function just like f is a function of your f of x only, then this is your two-dimensional, this is represent a 2D graph. If your function which is depend upon two variable, then this is your three-dimensional picture, so x quantity, y quantity and z quantity, or you can write your f quantity. So changing the value of x and y, so that will be decide your function f. So this is nothing but f plus delta f, which is nothing but f of x plus delta x. X it changes from x to where your y is constant, so we can write delta f is equal to f of x plus your delta x y minus f of your xy. Only we have taken this f over here, okay, so this will be the case. Now both side will divide with delta x, because here the change is only x, so delta of your x is equal to f of x plus delta x comma y minus of your f of xy divided by your delta of x, and then we'll take limit of both sides. Delta x tends to 0, this is limit delta x tends to 0, okay, means closer and closer value, so whatever the difference between them, this should be closer to the 0, so automatically you will get a more precise value, and this value is indicate the partial differentiation with respect to your x and where y is your constant, okay, or sometime you can write this is f of x, okay, f of x. So this is the partial differentiation of f with respect to the x, that time y is constant. So sometimes this is written over f suffix x. Same thing we can write for y also. So limit, similarly, y tends to 0. So here x is constant and y changes from y to y plus delta y. So this will give f of, instead of this is y is equal to limit delta y tends to 0. This is f of x comma y plus delta y minus your f of xy divided by your delta y. Okay, so this is nothing but what? Deba f by deba y over x is constant, or this we can write this is f of y. This is nothing but partial differentiation with respect to the y, that time x is constant. Okay, so this is about your partial differentiation. Means your quantity, means independent variables are 2 or more than 2. So the partial differentiation is play an important role. Okay, so suppose you want to see the differentiation of this particular quantities. So many times you will use the definition, and we are not using limit part, but you will get just like example over here. Suppose this is your square. Simple example I will take here. This is square and this is 3. This is your 3. And here suppose we have quoted this particular square with some quantity. This is also delta x and this also delta x. Okay, so this is the graph. It is just like f of x is a function of suppose x square. Okay, so this is nothing but what? Suppose we want to find out this is df by your dx, suppose. So we can directly find out this is 2x. But how the change is there in graphical way? So this is simple. This is what? This is f of x plus delta x. That is nothing but your x plus your delta x and its square. This is f of x, which is nothing but your x square. When you will find out this is f of x plus delta x minus f of x, which is nothing but x plus delta x bracket square minus your x square. So this is nothing but x square plus twice x into your delta x plus delta x square minus your x square. X square get cancelled. Now this is delta x. Now delta x is an infinitesimal change in x. So value of that is very small. Okay, just like 0.01 something, and you are taken the value of this is suppose 3. So in comparison with the 3, this is negligible value, and again you are doing the square of that one. So obviously the square is negligible, so we can neglect that particular term. This is nothing but your change in f. So this is df. Yes, so we can find out this is df is equal to twice x times delta x. Now our x quantity is what? This one, delta x. So you can find out how much the change in df due to this dx quantity. So this much you have quote on this one. So how much change? This much. Or suppose you want to find out rate of that one. So df divided by delta x. So that will give values twice x. Now see, this is 2x, this is 2x. So don't confuse, this value and this value is same, approximately same. So you will get the same result. Just like this is x cube. So you will write 3x square. If you do the same calculation, you will get the answer is also same. This is also change in function divided by change in that variable, but that is infinitesimal, or the super small change in function divided by super small change in your independent variable. Okay, so don't confuse this one. Again, one small case, I will take the example over here. So many times we can write this is d of sine of theta upon d theta is how much? This is cos theta. How we can take this particular quantity as a graphical way? So this is your circle. Okay, so here we can take this particular angle theta. Okay, so this side divided by your here. Okay, so that is represent what? This is your sine theta. Opposite side of divided by this particular hypotenuse. Now if your angle is increased with small this one, so this is nothing but your d theta. Okay, so in d theta case, the tiny step we can say. So if you are doing the tiny step and this is represent your right angle triangle, so at this particular point, what is the nature of that particular curve? So it is just like here. Okay, so this is your d means d theta, this is your d sine theta. Okay, and this is your angle theta. Okay, now this is your adjacent, this is your hypotenuse. So adjacent upon hypotenuse, please remember this is your theta component, this is your sine theta component, d theta component. When you are taken exactly here or here, I am drawing this particular graph is belong to this. Okay, so in this case this is your hypotenuse. So sine theta is my adjacent, d sine theta. Okay, and d theta is my hypotenuse. So you will get a cos theta value. Okay, so I think this is not confusing one, just you can see, you will get the idea. So that's why we can write this one. The next topic is your successive differentiation. Now in a successive differentiation, suppose you know this is delta f by delta x. Okay, at y is constant. Suppose this is again function of your x. This quantity is again function of your x. You have already taken a partial differentiation, just like example, suppose f is a function of your x square, and when you do this is delta f by delta x, so that is nothing but your twice x. Suppose you write here y, so this is 2xy. Now that's why we have to write this is depend upon x and y, so that's why we have write delta. So this is 2xy. 2xy means this is again function of your x, again function of x. Then we can go to the second order derivative. Okay, so this is your first order derivative. Second order derivative is what? This is delta by delta x. This is delta f by delta x. Then we can write delta 2f by delta x square. So same quantity we can write f of x. Now suppose delta f by delta y, x is constant, and you can write down delta by delta y. This is delta f by delta y. So that is nothing but delta 2f by delta y square, and this is your second order derivative in y. Then the mixed derivative, suppose this is your delta f by delta x, and suppose this is again function of your y also, so you can find out delta by delta y. So this is nothing but delta 2f by delta y delta x. You can write as it is delta y. But when you write a small, this is f of x into y. Okay, so this is not a big task. So suppose this is delta f by delta y, and this is your function. Okay, so this particular case you have taken, and this is again function of x. So same thing, delta f by delta y. So you will get x square. So this is function of x. So again partial with respect to the x. So delta 2f by delta x delta y. So this is f of y of x. So this is nothing but your second order differentiation. Okay. So if this is again function of your x, then you can go to the third order. Now you have question why we are finding out first order, second order, third order and all this thing. So you want to find out any nature of that particular. Suppose basically differentiation gives what? How your function is moving, slowly or fastly. That will be decide your slope. Okay. Now in this case, this is your first derivative, this is your second derivative. So again you are differentiating to the first and you will get second. Third order, so again you are differentiating to the third and you will get. So I will take one example so you will understand what I want to say here. Okay. So suppose you have one function. This is your x cube. Means f of x is your function of your x cube. Now I will plot a graph for x cube. So it is going just like this one here. So at this x value, suppose x values are positive, so this is going suddenly increase over here and this particular case. Now my aim is what? Find out the slope. So here suppose I will find out the slope, so it is also positive. Here suppose I will find out the slope, it is also positive. So it is continuously increase. So when I will take, this is instead of f, suppose we will write y, that is also okay for understanding purpose. So dy by dx, so that is nothing but your 3x square dy by dx. Why will write this one? Because we are finding out the slope over here. So this graph becomes, how to change? So this is my y, this is my x. Please, this is depend only on one function. So that's why we have written dy by dx. So you will get such a type of parabola. Okay. So this is 3x square. This is belong to your x cube. When you have taken the small change in y divided by this x, so you will get the differentiation rate of change of y with respect to the x. So 3x square you will get parabola. Now in this region you will get a slope is negative. In this region the slope is positive. So negative to the 0 and then it is goes to the positive region. Okay. And again I will find out the slope of this one. So this is nothing but d2 y by dx square. So this is nothing but 6x. So it is equation of your line plus center is origin. So you will get such a type of line. And this is your x. This is y, means this is dy by dx. This is d2 square y by dx square. This is one function. Okay, y axis. This is your x axis. And you will get line equation having the slope is 6. So over this particular line you can find out any points and you will find out the slope. So that is constant over here. Again suppose we will do the third order, then you will get a 6. But this is independent of your variables. Okay. So x is not there. So it is just like you will get one constant value. Okay. So this is basically, you can correlate your function with your graphs, and here the function is very just like this one. When you will do, you will get a different things, and this is the case. Okay. So in this lecture we have seen what do you mean by differentiation. Differentiation are useful for finding out how your function is varies. If your function is varies two or more than two variable, then we'll use the definition is partial differentiation. So in that, either you can write fx or your dy by x or something. Then we have seen one example related to that one, limit and all this thing. And thirdly, we'll see the successive differentiation. So if your function, once you differentiate, and again this is function of some quantity, and so you can go to the second order, third order differentiation. Okay, so with this I will